Okay.
Well, hey there, friends. This is Miss Berger.
And Miss Lamb.
And we're going to talk to you today about lines of symmetry, congruent shapes, and regular polygons.
Good grief.
That's a lot, but pretty simple stuff, so just stay with us.
All right. I can identify congruent segments. Congruent we know means equal. Oh, sorry, segments and polygons with corresponding parts. Oh my gosh, it was a whole sentence here. I can identify congruent segments and polygons with corresponding parts. I put that all in one color.
Identify regular polygons.
And identify lines of symmetry. Wow.
Wow. All right, so let's dive into this. What does it mean to be congruent, and what does it mean to have a corresponding part? So the word congruent means identical, like same size, same shape, same measurement, right?
Mm-hmm.
So congruents are like equal, totally identical. So no, you go.
Okay, so similar is it's the same shape, but one is bigger or smaller than the other one.
Yeah.
So basically similar, you know, here's two pentagons, but they're two different sizes. Here's two triangles, but they're two different sizes. The congruent ones are absolutely identical. Even if they're turned in different
rotated, they are identical. So congruent, identical, similar, same shape, maybe different. The same angle measurements, but different like length of the sides, right? Mm-hmm. So when we're looking at congruent lines, there's ways to show that things are congruent. And I always call them these little like congruency dashes. Is there an official name?
I don't think there is. Tick marks is just as
little
good.
Tick marks, dashes, right?
Whatever.
So I could show that this line is congruent to this line by showing these, they both have the kind of the same tick marks, right? There's two up here, there's two down here. Mm-hmm. On a triangle or another kind of closed figure polygon, right? So like I could look at the corresponding parts by showing these tick marks, right? One tick on this one equals one tick. So line segment AB is congruent to line segment ED. Oh, sorry, no, it would be DE. Sorry, this is that one, line segment that one. So I could show line segment AB, we have to learn all these parts, right, is congruent. An equal sign with a little fancy, a little swirly thingy, is congruent to line segment DE.
And the reason you're saying it has to be in that order is because of this little single
call them angle
arcs.
Is that what they're called officially?
Yep. Angle arc right here. There you go.
So I could say that angle A is congruent to angle D, right?
And you so on and so forth. You could do it all over the place.
So one tick mark is one tick mark. The two tick marks would equal two over here. One arc matches one arc.
Oops.
Two arcs matches two arcs. Three arcs matches three arcs, and so on and so forth, depending on how many angles there are. So you can use those kind of clues to show what we call corresponding parts, right?
Yeah.
The part on one polygon that matches the part on the other polygon.
And the reason we threw this one in is because, first of all, it is all labeled with the little tick marks, and there's even 4 tick marks on this side.
Yeah.
4 right there. And you can kind of see how they even rotate them to try to trick you. But if you really look at those tick marks, that's your first line, and those little angle arcs.
Can I show a little trick?
Sure.
Okay, so here's a little trick. So this says ABCD is congruent to EFGH. So I write them kind of above each other. ABCD is EFGH. And if I line them up, it shows like the corresponding sides. Like angle A is congruent to angle E. So here's A, here's E with their one ticks, right? Line segment AB is congruent to line segment EF.
Absolutely.
And like D equals H. And so if you kind of like organize them that way, then you don't have to try to travel around the polygon. You can see them kind of just right here.
And I know this looks like 3 equal signs, or 3 equal, it really is the congruent line.
And a little squiggly.
A little squiggly. The equal sign and a little squiggly.
So identifying congruency is pretty easy, right? Are they the same size, same shape? The harder part when we start talking about the corresponding sides, which we'll practice together.
Yeah, that's a little bit more complex.
All right, well let's talk about regular polygons.
Regular polygons. Well, first of all, a polygon is a closed figure. Okay, closed figure, and it has to have line segments. So in other words, a circle is not a polygon because it doesn't have line segments around it. So anyway, here's some examples of them, and I think we've got a 3-sided, 4-sided, 5, 6, 7, 8, 9, 10, and then 12. We actually jumped from 10 to 12.
Dodecahedron.
Dodecahedron. Or dodecagon, because it's not a hedron. But
oh,
that's
you're
okay.
right. A dodecahedron would be three-dimensional. Sorry.
And then just kind of put these in
As
here.
you can tell, I struggle with measurements.
I love geometry and measurement. All right, and then we added this one in because it had this little extra thing here about in an equilateral triangle, all the inside angles are exactly 60 degrees. On a four-sided quadrilateral, or in this case the square, all the angles are 90 degrees. The 5 angles are 108 degrees. So if you look at this, it's a little bit extra information, you know, maybe not needed, but that just shows that all the angles inside are all identical. They're all the same in all the regular.
They are congruent.
They are congruent, and all the sides are the same lengths, and the angles are the same.
Right. And you do not have to memorize all of these angle measurements. We will talk about quadrilaterals, and you have to know that all 4 of the angles are 360 degrees. But other than that, that's the only measurement you have to memorize.
Yeah. And that's in your digital notebook. I call it.
All right. And then the last thing we're going to cover is lines of symmetry. You know what's so crazy is that my second grader is doing lines of symmetry right now.
Yes.
And then we still talk about it in the 6th grade, which is just kind of crazy that you guys have seen it so many times.
Yeah.
But a line of symmetry is when you split the polygon in half and it forms like this mirror image of each other. Mm-hmm. So if I were to like fold this rhombus, right, then they come up like perfectly together. Yep. If I like split it vertically or horizontally, right? They come up perfectly together. So lines of symmetry create this like kind of mirror effect.
And some things like this particular trapezoid doesn't have a line of symmetry.
No.
The parallelogram does not have one.
No.
So each one, now regular polygons, a really cool thing is if you're a regular polygon, the number of sides are the number of lines of symmetry. So a pentagon, 5 sides, 5 lines of symmetry. A hexagon, 6 lines, 6 sides, 6 lines of symmetry. So,
I didn't know that.
Yeah,
that's so crazy. Neither did Mr. Lamb, who's behind the camera.
Okay,
I know.
The thing. I was going to write regular polygons, but that only works for the regular polygons. Just heads up.
Not the irregular ones.
No, not the irregular.
All right, so as we go forth, if you are confused about the kind of anything we covered, watch that additional video. It's always helpful. But if not, if you feel like I got it, I'm ready to practice, go forth, be awesome. We'll see you later.